Hello students, this is Professor Chalai, and in this video we're going to look at concentration by volume percentage. By the end of this video, you should be able to perform various calculations using the percent volume concentration. As always, you can follow along with our Chapter 3 workbook. Now, just to summarize what we've talked about a little bit throughout this chapter in terms of concentration is often a measure of the amount of solute over the amount of solution. And the units or the types of concentrations that we've used so far in the course varies. For example, if we use moles for the amount of solute, instead moles of solute, and instead of for amount of solution, we use liters of solution, we get what we call the molarity, or big M. However, if we use for an amount of solute, we used mass of solute divided by mass of solution times 100%, we get what we call the percent mass, sometimes given as percent W over W. In this video, we're going to look at the third type, where for the amount of solute, we'll use volume of solute, and for the amount of solution, we'll use volume of solution times 100%. And this comes in useful when we have liquid dissolved in a liquid, where liquids are more easily defined by the volumes that they have. And if you've guessed it already, we'll call this the percent volume concentration. And sometimes you'll see percent volume or percent V over V for volume divided by volume. All right, so let's do some calculations with concentration by percent volume. Since you've had some practice already doing percent mass concentration, percent volume should be no different, except now we're dealing with the volume of a substance rather than its mass. So let's see if you can handle number 37 and 38 by yourself. Pause the video and then on pause and I'll go over them together. Okay, so let's look at number 37. In number 37, we have rubbing alcohol or isopropanol, which is a 70% volume aqueous solution. So right away, we know that our solute is isopropanol. And our solvent, it says it's an aqueous solution, so our solvent is water. And they give us the percent concentration by volume, so it's 70% V over V, or volume. Okay, it gives us the density of isopropyl alcohol, and it's asking us for the grams of isopropyl alcohol. And then it gives us the volume of the alcohol. So we know that the percent volume over volume is equal to volume of solute over volume of solution times 100%. They give us the volume of the bottle, the volume of the solution, so we have that. They give us the percent volume of the concentration, so we have that. So we can solve for the volume of solute, which is the volume of isopropanol. So let's rewrite this equation to solve for the volume of the solute. So volume of solute, isopropanol, is our percent volume over volume divided by 100%, right? We divide both sides by 100, multiply both sides by volume of solution to get where we are here. So volume of solution. So let's solve for that. So the percent volume over volume would be 70% over 100% times our volume of solution. It tells us that we have a 355 milliliter bottle. So we plug this into our calculator and we get 248.5 milliliter. Just remember that we have 1 sig fig, so I'm just going to put a 1 sig figs there to remember that our answer should have 1 sig fig. Okay, we have the volume of solute But that's not what the question is asking us for. It asks us for how many grams of solute we have. Isopropanol is our solute, and it wants the grams. We have the volume. But we do know that if we have the volume and we have the density, we can find the mass. So the mass will be equal to the volume, 248.5 milliliter, times the density. And the density is 0.785 grams per milliliter. So you plug those numbers into your calculator and you get about 195 grams of isopropanol. Remember, we said that we should remember that our answer will have 1 sig fig. This answer should have 1 sig fig. So I'll just round that up to 200 grams as our answer. Again, this question gives us the percent volume concentration and the total volume of solution, which means we could use that to find the volume of solute. Once we have the volume of the solute, we can use the volume and the density to give us the mass, which is what the question was asking us for. Okay, let's look at number 38. Number 38 is looking at a wine solution that is 12% ethanol by volume. Wine, like many other things, is an aqueous solution where the solvent is also water. Okay, it gives us the molar mass of ethanol, the density of ethanol, and it's asking us for number of moles of ethanol. And it tells us we have a 750 ml bottle of wine. So we have the percent, 12% volume. We have 750 milliliter solution, right? That's the total bottle of wine. It's a solvent and solute mixed together. It's a solution. So if we have the concentration and they have the volume of solution, we could find the volume of solute. So let's do that. So 12% volume over volume should be equal to the volume of solute over the volume of solution, which is 750 mils times 100%. So let's solve for the volume of the solute. So volume of solute is equal to 12% divided by 100%, right? Multiply by 750 milliliters. Plug all of those into your calculator and you get 90 milliliters, 2 sig figs. So that should be 2 sig figs. Okay, so we have the volume of our solute, which is the volume of ethanol, but they're asking us for moles of ethanol. All right, so how do we figure this out? All right, we need moles of ethanol. We start with 90 mils as our volume. We know that we can convert volume to mass using the density, which they give us. The density was 0.789 grams per milliliter. And we know we can convert from grams to moles using the molar mass, right? They tell us that the molar mass of ethanol is 46.06 grams per mole. All we need to do is make sure that we divide so that we cancel out our grams. And we plug these numbers into our calculator and we get 1.5 moles to 2 sig figs. So this one takes it a little step further. The first step was to find our volume of solute. We have the concentration, we have the volume of solution. Once we solve for the volume of solute, we use the density to convert to mass, and then we use the molar mass to convert to moles, which is what the question was asking us for. All right, before I end this lecture, I just want to point out that there is a third way to measure concentration in terms of percentages. And here it's sort of mixed mass and volume. Sometimes we call it percent mass over volume. Percent mass over volume. Or sometimes we call it percent weight over volume. And as you would guess, we would use the mass of the solute, but rather the volume of the solution times 100%. And so that's concentration by mass volume percentage. So there are 3 different ways to calculate concentration by percentages. We have up here mass percentage, where it's mass of solute over mass of solution. Here we have the volume percentage, where it's volume of solute over volume of solution. And here it's mass volume percentage, where it's mass of solute divided by volume of solution, all expressed as percentages. All right, if you have any questions, please let me know, but this will bring us to the end of this lecture. I'll see you in the next one. Bye.